Hello friends, today we are going to start with a new chapter in chemistry for standard 8th ICSC, that is chemical reactions. So as per Viraf Dalal textbook, it is chapter number 6. So chemical reactions. In our earlier chapter we had learned about language of chemistry, and in case of language of chemistry we understood that how the equations are going to be written and are going to be balanced. So we learned that how the reactions are going to be shown in a form of an equation. In this chapter, what we are going to learn is what are the different reactions or what are the different methods that a chemical reaction could take place. Okay, because chemical reaction whenever it's taking place, it could be between two elements or one element and another compound, or two compounds, or one metal and another non-metal, or both non-metals. So it can be many different ways that the reaction is going to take place. So depending upon how the reaction is taking place, we are going to have this understanding in this chapter, that is chemical reactions. So firstly, if you want to define a chemical reaction, the chemical reaction is a chemical change in which matter changes into a new substance or substances. So when any matter is going to change chemically, okay, there is a permanent change. Chemical change is a change in which a new substance is going to be formed. So automatically a chemical reaction is a chemical change in which a new substance or substances are going to be formed out of a matter. So the matter changes into a new substance or substances. A chemical reaction is often accompanied by external indications or characteristics. So yeah, whenever an chemical reaction is going to take place, many a times there will be some or the other indication which will be noted during the chemical reaction, like change in color, gas bubbles given out, heat given out, okay, some fluorescence, that is light given out. So there could be some or the other kind of indication which could be available whenever any chemical reaction is going to take place. So some of the indications which normally does take place in case of chemical reactions are given below. So first thing is change in color. So the first indication could be there could be a change in color of the substance. You take a particular, like for example, if you take copper sulfate, which is a crystal, it's a blue colored crystal. So hydrous copper sulfate, which is a crystal, when you are going to heat it, it is going to turn into white colored powder. So there is a color change. Okay, there is a color change which is taking place whenever some reaction. So one of the very easily noticeable thing what would take place in case of a chemical reaction is the change in color. So they are given the example over here of mercuric oxide, MgO, which is red in color. So we have got over here that HgO, when it reacts or gets heated, it is going to give me Hg plus O2. To balance it, we are going to put this 2 over here. So this over here is red in color, but on heating, this is going to become silvery gray. Okay, the silvery material, that is nothing but mercury. We know that mercury, we have seen mercury. Mercury, we have seen it in a thermometer. So the silver colored mercury is going to be seen when a mercuric oxide, which is red in color, is going to be heated. So that color change is easily seen. So that indicates that some kind of a reaction does take place in that particular chemical equation. The next is effervescence or evolution of gas. What is effervescence? The bubbling up of gases. You know, कभी भी हम लोग एक थम्स अप का बॉटल अगर खोलते हैं तो what will happen? अंदर से पूरे सब bubbles निकल लगते हैं. You will find that there are small bubbles coming up from bottom to the top. So what are those? They are nothing but evolution of gas. Okay, of course, thumbs up में जो है, that is just not a reaction taking place. It is just that some compressed carbon dioxide was pressed inside that particular liquid जो धीरे धीरे बाहर निकल रहा है. सोडा, कोई भी सोडा लेंगे, not even thumbs up, any soda which you are taking, the soda will always give you a particular kind of that is nothing but carbon dioxide which is going to be given out by that particular liquid continuously. So that particular way the bubbles comes up, okay, that is called as effervescence, that is evolution of gas. So in this case they are given you the reaction in which when zinc, so second one is gas release, okay, so that is evolution of gas, also called as effervescence. It is effervescence, okay. So the example given over here is when zinc is going to react with dilute HCl, it is going to give me ZnCl2 plus H2. So this is the reaction which is given over here. Of course we need to balance this thing, we just put a 2 over here, yes. So here this H2 which is there is going to come out as a gas. So there will be a continuous evolution of the gas, of hydrogen gas, which will be evolved in this particular condition. So this is effervescence. So the next thing what we have is effervescence. The third one is evolution or absorption of heat. So evolution or absorption of heat. So the third one is heat is going to either be evolved or absorbed. So either it is going to evolve, that means it is going to produce heat, or it is going to absorb heat, so take in heat. When it is going to produce the heat, heat is evolved, is called as exothermic. And this is called as endothermic. Exo means exit, means heat is going to be given out, okay, getting out is exit, that is exo. Exo is exothermic, means heat given out. Endothermic is entering of the heat. Heat is absorbed inside, so that is endothermic. So whenever any particular reaction is evolving, is giving out a heat, then it is exothermic, and whenever it is taking in heat is called as endothermic. So whenever any reaction is such that when you heat it, only then the reaction takes place, we call it as endothermic, and in which there is no need of heating required, but in fact when you are here to the reaction takes place, it is going to get a bit warmer or hotter. That is nothing but the exothermic reaction. So in case of exothermic, the reaction is of calcium oxide with water. So अगर थोड़ा चूना अगर हाथ में लेंगे, calcium oxide is nothing but चूना, तो चूना अगर हाथ में लेंगे और थोड़ा पानी डालेंगे, you will find that it will slowly feel hot on your palm, okay. So palm में थोड़ा गर्म लगेगा, that is nothing but exothermic. So the reaction for exothermic is CaO plus H2O gives me CaOH twice over here. So this is CH twice plus a lot of amount of heat. The heat is denoted by triangle. The triangle over here denotes the heat, okay. So that is the heat which is given out. Where in the same case, if I am taking nitrogen and reacting with oxygen, I get 2NO2. Sorry, it is just yeah, we have to balance this thing. I'll just take 2NO. So in this case, the heat is going to be taken in. So this is going to take place only when heat is taken in. So when the heat is being taken in, it's called as endothermic. So this reaction is endothermic and this reaction is exothermic, okay. So that was endothermic and exothermic, that is absorption or evolution of heat. The lastly is formation of a precipitate. So precipitation. Now many reactions will give rise to a compound which is insoluble in the substance, and that's why they will settle down in a particular white curdy precipitate, or maybe some brown color precipitate or green precipitate or a brown precipitate, कुछ भी तो वहाँ पे नीचे precipitate मिलेगा. So that is insoluble part of the reaction. So after reaction, if that particular compound becomes insoluble, what we are going to get will be a precipitate. So similarly over here, that certain chemical reactions characterized by formation of insoluble precipitates So silver nitrate, when it reacts with HCl, so AgNO3 when reacts with AgCl gives you AgCl2 AgCl plus HNO3. So this over here is a precipitate. So this one, the precipitate is shown as a down arrow, okay? Gas is shown as an up arrow. So over here, gas is going to be given as up arrow. This is up arrow, okay? Whereas the down arrow means precipitation. So this is the precipitate. AgCl, that is silver chloride, is a precipitate. The silver chloride is a white, milky white precipitate. It is also, in a short form, we say at PPT. Okay, PPT means precipitate. So in this way, we have the formation of a precipitate as the fourth kind of result of any reaction. So we see that the characteristics, indications of any chemical reaction taking place could be either the color change, there is a color change, red to silver, ऐसे कोई color change होगा, या तो there is effervescence, that is the evolution of gas. So gas is going to be given out, evolved, and that will bubble out through the thing. So bubbling out of the gas is nothing but effervescence. The third thing could be the heat is going to either be absorbed or it is going to be evolved. If it is evolved, it is called as exothermic reaction. If it is absorbed, it is called as endothermic reaction. So these are the examples of exothermic and endothermic reaction. And finally, if it gives rise to a insoluble part of the compound, then it will be an insoluble precipitate which will be formed, which is called as precipitation reaction, which is indicated as a down arrow inside the equation. So this way you have got the different characteristics, indicators accompanying a chemical reaction. So change in color, effervescence or evolution of gas, or an evolution of heat or absorption or heat. That exothermic proceeds with evolution of heat energy represented by plus triangle, and endothermic reaction proceeds with absorption of heat energy represented as minus triangle. And finally, formation of precipitate, certain chemical reactions characterized by formation of insoluble precipitate, that is nothing but silver chloride, which is going to be formed, which is milky white precipitate. So these are the different examples of the characteristics, or you can say that indicators for a reaction to take place. Now, if the reaction is going to take place, the reaction is going to be present, or it's going to happen in four different types. So there are four different kinds of reactions which can take place. One is a direct combination, or also called as synthesis, decomposition, that is the splitting, the displacement reaction, that is substitution, and double decomposition reaction, which is also interchanging of the ions. So we say that the direct combination is the reaction in which two or more elements or compounds combine to give one new compound. So what I'll do is that instead of going through the main type summary over here, it is better that we go for the detailed thing in the next page. So we start with the page number 62, which tells you about the direct combination reaction, and so on. So we are skipping the part 61 because it is just a summary of what we are going to learn in the later part of the chapter. So we'll just start with the summary part, and summary part का सिर्फ heading देखेंगे और फिर अंदर जाएंगे, फिर से वैसे we'll just go through it that way. So we'll keep on referring to page number 61 again and again when one particular kind of reaction is understood. So the first thing we see is the reactions are going to take place in four different methods, or different types of reactions. There are four different kinds of reactions. Of course, there are another also, but the main ones, which are going to be the key ones, you can say, they are four in nature. So first one is called as direct combination or synthesis reaction. So direct combination or synthesis reaction, it is a reaction in which two or more elements or compounds combine to give one new compound. Okay, so if there is element A, reacting with element B resulting into AB, then such a reaction is called as a simple direct combination reaction or synthesis reaction. Okay, so this could be, of course, multiple types. Like for example, there A could be a metal, B could be a non-metal, and accordingly a reaction is going to be given where metal and non-metal are going to combine together. It could be that A is an element, B is an element, and both combine to form a compound. It may happen that A is an element but B is a compound and giving you another compound. Or maybe that A and B both are compounds and they combine to give you a new compound. So there could be many ways the compounds or elements are going to combine together to form a new compound. Okay, but mainly what is going to happen is that two or more compounds or elements are going to fuse together to form a new compound, which is nothing but direct combination reaction. The example over here would be iron and sulfur giving you iron sulfide, Fe plus F giving you FeS. So direct combination reactions are those also called as synthesis reaction. It is chemical reaction in which two or more elements combine to form a compound, that is A plus B give you compound AB. So element A, so it could be, first condition would be element A plus element B giving you a compound AB. Okay, so element A plus element B giving you a compound AB. Like for example, this could be Na, this is O2, so sodium plus oxygen is going to give you Na2O twice. Okay, so element plus another element giving you a compound. We can also say metal reacting with a non-metal to giving you a compound, right? So kind of a salt. The same way, it could be calcium plus oxygen giving you calcium oxide. It could also be a non-metal reacting with a non-metal. So here it could be either, so in this case it is a metal. It could also be a non-metal reacting with a non-metal, like C plus O2 giving me CO2. So this is the non-metal reacting with another non-metal to give you a compound. Right, so you can see that it could be two elements, one metal, another non-metal, or both non-metals reacting to give you a compound. Normally two metals will not react with each other. Okay, two metals don't react with each other. That's why you do not have the option of metal reacting with metal to give you another compound. Okay, that's not possible. So that's why they are giving you the example over here of element to form a compound. In case of metal plus oxygen is giving you metallic oxide, that is Na plus O2 will give you 2 Na2O2, Na2O. 2Ca plus O2 giving you 2CaO. Non-metal plus oxygen giving you non-metallic oxide. C plus O2 CO2, S plus O2 SO2, 4P plus 5O2 giving me 2P2O5. The next example could be a compound reacting with the element. Okay, so there is a compound reacting with element. So this is the compound. Now this is the compound CO2. So suppose you have got a compound which is CO2 reacting with an, or we'll just take CO reacting with O2 giving me over here 2 CO2. Okay, so this reaction is wherein this is a compound, this is an element giving you a compound. So you can see that it could be that A is a compound, B is an element giving me AB, which is a compound, right? So CO plus O2 giving me CO2, 2SO2 plus O2 gave me 2SO3. So this is again between a compound and an element. Got it? The next one is compound reacting with another compound. Okay, when two compounds are going to react with each other. Just erase a part of this. Now these examples are going to be slightly important because all these examples you may need to learn, as this could be a way to write your answers because they may ask you some example of the same. So compound reacting with a compound. So you have your metallic oxides like Na2O plus H2O. Now this is a compound, this is also a compound, giving rise to 2NaOH. So this is also a compound. So compound plus compound give me a compound. Okay. This is a metallic oxide plus water giving me compound. Another could be CO2 plus H2O giving me H2CO3. So that is acid. Okay. So remember one thing. Now something we are coming up over here to with something which is very important in chemistry. Okay. Now this is a metallic oxide. A metallic oxide, when it reacts with water, it will give you a alkali, that is a base. Okay, it will give you a base or an alkali. Where we call it. See, what is the difference between a base and an alkali is that all alkalis are bases. But alkali में और base में difference ये है कि alkalis are soluble in water, whereas bases are not soluble in water. Okay, all the bases may not be soluble in water, but all alkalis are soluble in water. So that's why all alkalis are bases, but all bases are not alkali. Okay, because base पूरा एक पूरा unit है, उसमें से कुछ ऐसे जो soluble in water है, उसको हम लोग क्या बोलते हैं? Alkali बोलते हैं. Okay, so alkalis are those which are soluble in water. Right? So how are the alkalis formed? They are formed when a metallic oxide reacts with water. So metallic oxide reacts with water will give you an acid. Whereas a non-metallic oxide, when it reacts with water, it will give you an acid. Okay, non-metallic oxide plus water will give you acid. This is a very important thing to remember in chemistry. Chemistry mein, this is one of the important part, that when an metallic oxide reacts with water, it forms a base, whereas when a non-metallic oxide reacts with water, it forms a acid. And that's why the metallic oxides are called as basic oxides and the non-metallic oxides are called as acidic oxides. Okay? This is the basic oxide and this is the acidic oxide, right? So because this reacts with water to form acid, that's why this is an acidic oxide. This reacts with water to form a base, that's why it's a basic oxide. So we see that N2O plus H2O gives you 2NaOH, CaO plus H2O gives me CaOH twice. Non-metallic oxide with water में CO2 plus H2O gives me H2CO3, SO2 plus H2O gives me H2SO3 and P2O5 plus H2O gives me H3PO4. So 2H3PO4, that is nothing but phosphoric acid. So in this way you are going to have the direct combination reaction or synthesis reaction, which is going to be such that it could be between two elements to form a compound, one element, one compound to give you a compound, or two compounds reacting to give you another compound altogether. So this is called as direct combination reaction or synthesis reaction. The basic structure is A plus B is AB. Okay, A reacts with B to give you AB. Okay, A plus B gives you AB. This is the standard general form of the direct combination reaction. We now move on to the next one, and that is the decomposition reaction. One more thing in the direct combination reaction is there is one more example over here where two neutral gases, that is ammonia and HCl. Ammonia and HCl are going to react with each other, and so one acidic and one basic oxide. HCl is an acidic oxide, and so this is an example over here that you have got NH3 plus HCl giving you NH4Cl. This is also an example of direct combination reaction. Other example which is given over here is in the textbook itself in the first part, that is Fe plus S giving me FeS. So this is also an example of direct combination reaction, or we can say synthesis reaction, right? Okay, now for the decomposition reaction, I'll just take in the next video.